Its inputs and outputs are sometimes called features and predictions, and they take the form of vectors, arrays of numbers. The overall function is made up of lots of simple functions called neurons that take many inputs but only produce one output. Each input is multiplied by its own weight and added up along with one extra weight called a bias. Let's rewrite this weighted sum with some linear algebra. We can put our inputs into a vector with an extra 1 for the bias and our weights into another vector, and then take what is called the dot product. Let's just make up some example values. To take the dot product, we multiply each input by each weight and then add them all up. Finally, this dot product is then passed to a very simple activation function, in this case a ReLU, which here returns 0. We could use a different activation function, but a ReLU looks like this. The activation function defines the neuron's mathematical shape, while the weights shift and squeeze and stretch that shape. We feed the original inputs of our network to a layer of neurons, each with their own learned weights and each with their own output value. We stack these outputs together into a vector and then feed the output vector as inputs to the next layer, and the next until we get the final output of the network.